and a list of points denoting that curve. To get those points, we need to find the line of translation. So from here to here, from here to here, from here to here, from here to here. Okay. Once we find that line, we then need to divide that into the certain number of steps that we want to go from the beginning to the end. And then there's a point somewhere on there that we can grab the same point along each of those connecting lines and then draw our curve from it. So let's first connect all of our lines together. So divide curve returns us a list of points. So that is an array. So this is an array of points in plan. And this is an array of points in section. Now we're going to, we will loop through all of the possible curve divisions and connect point A with point B. So we would say, for every point in the first list connected with the second. Okay. Now this is where we need to decide what type of for loop we want to run. The syntax, the easy syntax that we saw earlier when we said for a variable in a list would not work here, because we need to get a point such as this point here could have an index of 20, correlated with a point here that has an index of 20. So in this list, index 20, in this list, index 20. Now if we say for each variable in a list, we don't know what index we're on, and so we couldn't get the coordinating point in the second list. Okay? So what we need to do is that syntax that said for I in a range from 0 to the length of this list. Okay? So for I in range, starting at index 0 and going to int curve divisions. But int curve divisions, we need to think about this. Is that the length, is that really the number of points that we end up with? No. When you divide a curve, you get 100 segments, but you get 101 points. So we actually need to add 1 to the length of this. So this gives us the total number of points. As a habit, let's put in our step size of 1. So each time the loop runs, it will increment up by 1. Okay. So now we can now draw a line from the beginning to the end. Okay, so if a line starts here and ends here, we say that the starting point, call it array start point, equals, and what does it equal? We need a point, some point on this line. We have a list of those points. What do we write here? What is a point on this list in the current loop? It is array points plan, but what is the index? Should be really easy. It's not a hard answer. If we're looping through for index I in range 0 to the total number of divisions, what is the index variable for each item in string plan? here. Okay? So for every index I in a range from 0 to the total length of that list, okay? So each time we're going to be looking at an index I along this list. Okay? So we're going to write here array points plan index I. Now we're going to do the same thing to get the corresponding point on the section curve, which becomes the endpoint. So array endpoint equals array point section index I. Now we can just draw a line between them because we looked at the add line command last week. So the line would be rs.addLine, the array start point, and the array endpoint. Save the script. And select the beginning curve, end curve, and then we run into a problem. It says name int curve, it's a typo. So it says name int curve divisions is not defined. That's because here, I forgot an I. It tells us what line that error occurred on. Okay? So when we run it and we get a red window that comes up here, look at the traceback, see what line it happened on. Line 11 corresponds to here, and then read what the message is. So name int curve divisions is not defined. So I had a typo in int curve divisions. Okay. Start curve, end curve, and it draws all of the lines for us.
Why do you have to go back and click it? If you don't click it, nothing will happen.
Click what?
You go back to the Rhino.
Click here?
No, after that
Here?
you go back to the window, yes.
I clicked here in order to undo the previous run. Okay? Even if you get an error here, you will get geometry every point up to that error. Okay? So if you were, for instance, dividing curves and showing points, so showing points, up to that error, since that's before the error, you'd get points on the screen. If I run this again, it'll put another set of points on the screen.
I see. But then, like, after you undid it, you press run again, and then you go back to the window and you click the two curves.
Yes, because every time you run the script, it runs fresh. It has no memory of the previous run.
Right.
If you want to get into issues of knowing what was previously run, and you can store, for instance, your lists as external text files, and then reread those each time the thing runs. Okay, so you're essentially building your own program every time you do this. That's why it's called programming.
How do the computer know which line is sections, which line is plan?
Because I clicked on it.
So it's right before.
Anytime you run the get command, you're asking for user input.
You click it, you go back to the Rhino and click the line.
This message will show here, and then I click the line. This message shows here, I click the line. All of these.
係好迷啊 I think it's so clever that 係咯。
Okay, so all of anytime you need input from the user, and most of the time that user is you, there are always usually going to be get something. So if you need an integer, you get int. If you need a decimal, you get a real number. If you need an object, you get the object. anytime you want to add geometry to the screen, those all start with add. So that gives you an idea, at least to start with, of where the commands, what they would be.
即係你打咗 get object 佢就會企咗咯，然後佢叫你撳一撳嗰條線。但係我又見唔到佢撳嘅，點解見到喎？你見到啊？我就以為佢係 clear 定係乜鬼嘛，成個。佢頭先有冇做 flip 嗰個過程
Now this gives us the transformation vectors from here to here. Now we need to draw lines along these transformations so that we can see all of the various possibilities between here. Now conceptually, this is a smooth transition. Realistically, if we wanted actual iterations or an animation, we need to get specific points along these lines. Okay? So we find a point here, we get its corresponding point here, and we draw a line across the whole thing. So what that means is similar to how we did this and divided that curve to match this curve, we now need to divide each of these curves to match their corresponding curves across the whole set. So, we've added a line. So now, if we said for I in a range of all the curve divisions, we also need to say for j in a range of all of these vertical line divisions. Okay, we need to divide these up and loop through all of those in the same way. We're using j here because we are nesting our loops. Okay, we are forming a loop within a loop. Okay? You can see that we stay on the current indentation level. Python is strict on indentations, so since we're not inside of a loop here, everything is left aligned. Now that we're in a loop, it is indented once, which is 4 spaces. You can push tab, it will create them. Now we're forming our second loop, so everything inside the j loop will have to be indented inside here. We have to have the loop inside here. If we had it outside, we wouldn't have access to each of the lines. Because we haven't stored them in a list, we haven't done anything. So every time this loop runs, it's adding a line. And we're going to store it into a variable, divide it, and then loop through. So let's divide each of those verticals. Now we don't know, or we need to specify another variable, which is how many steps do we want to have along here. Let's take it easy for now and say we only want to see 5 steps. We only want to see 5 possibilities. So we're going to have, I'm going to make another variable called int frames. Okay, that's the number of frames that we want to see between these two curves. And we'll set that equal to 5. And we're going to divide each of those lines. So string line equals the line that we added. So rs.divide curve. String line is the curve ID, and the number of segments is going to be int frames. Since we're going to loop through them, we need to set that equal to a list or a variable. So let's call that array points. Let's call it line just for consistency. Since we call this string line, let's call this array points line. And then we loop through each one. So for each string line, actually no, for each for j in range from 0 to the number of frames, and similar to how we had to put a +1 on the curve divisions, since these are also curve divisions, we need to add a plus 1 as well. So this gives us all the various points. Let's actually see our points here as well. So when we divide the curve, let's also set this to true. When I run it, I'm going to temporarily, just so we can see what we're doing, run the code, select the beginning line, the ending line. It draws all of the lines and all of the new division points. So now we can already see that we have all of the points we need to redraw each of these lines. Now the fun part. Okay. The whole trick to doing this now is that we need to get all of these points in a list. We need all of these points in a list. But as we are doing our code right now, a rate points line is a list of this point, this point, this point, this point, this point. Okay? It's a list in this direction. We don't yet have a list of points in this direction. So we actually need to flip the matrix so that we now, so that we have the row instead of the column. Okay. For ease of, more for visual ease, I'm going to say now for call. Okay, I'm going to say this is a column now. So each of these is a list of points in this direction. Just for my own knowledge, I'm going to call it, I'm going to say the variable, instead of j, I'm going to say column, so that I know that this is the column, and I'm trying to form a row. The row is I, actually. Because we were saying, actually, no, it's not. That's not the row. Oh, okay. The row is actually the curve division. Okay, so that's the. This is the row. Sorry. The row is the frame. So for each row in these lists. That's a little bit confusing.
Very confusing.
That happens all the time in math. You do a very, very simple thing, and it's a very simple geometry thing, and it boggles the mind completely. It's actually more straightforward if we use this row-column terminology. Okay, so this, the list that we want to loop through is a rate points line. A rate points line represents the points along this line. Okay? These are the rows that we want to form the line this way. So we're going to say for each point, or for each row in this range, do something with that point.
We're not doing the line on the plan and the line from the section, right? Because that was already a line.
These are already lines. We're going to draw
the
these.
4 lines. So why is in frames plus 1 instead of minus 1?
Okay. Yes, it will redraw the beginning and the end.
Yeah.
That's not a bad thing, because if we want to animate it later, we only want to grab the geometry we end up with.
Okay.
So it's not too bad to recreate this line.
Okay.
If you want, and imagine the complexity of the workaround. You would have to say, take off the end 2 points, and so you'd actually have to say, for in range, index 1. Okay, so start with this point and go to 1 before the end.
Right.
A little more complex, but we could do it that way. Okay, so for each row in that range. Now we need, we actually, what we need to do, since we need a list, we need this list, we need to create a blank list to store that stuff in. Because every time we're running through this, this line has no knowledge of any other line here. So we can't create the list. So that tells us that the list needs to be something that's outside the loops.
其實做功課係咪照抄翻一次就得？
So I'm going to make a new list.
我覺得
And
做
so
功
we're
課
going
如
to
果
introduce
我做
one
都
new
要照
bit of
抄一次
syntax.
咯。
And that is how you create a blank list.
我覺得做功課唔會抄嘅，我會講數字嘅。你錄緊音嘅時候唔可以抄嘅，跟住你10日揾先。
如果唔係點？
我唔會抄嘅。
Just call it array div points. And we could say that, this is a list. Okay? We're going to try and create a list of 1, 2, 3, 4, 5, 6 items that is also a list of points. So this is a nested list. Okay? So we have a list of 1, 2, 3, 4, 5, 6 rows that has this many columns in it. This many columns in it, etc. Since we want to store these things into a list, we need to specify the size of that list first. In Visual Basic, you always have to do this. In Python, you don't always have to specify the initial size, but for this example, we do. The reason we do is if we want to access, for instance, the row and the column and set it equal to something. Okay. So for instance, if we wanted to say array div points row column equals a particular point, okay, we can't actually create that because it doesn't know that row index something is a column or is a list. Okay. So we have to specify the size of this initial list. The syntax in Python is unique for that. And how you specify a list with a particular number is you create an empty list by saying this is a list of values none, and then you multiply it by the number of items in that list. The number of items in that list is frames plus 1.
係咪 hea 咗
Okay, because that's the number of rows. So we are creating a list called array div points that is going to be a list of columns within a list of rows. Okay? That list of rows is going to have a length or a size of int frames plus 1. So we're creating 6 rows. 1, 2, 3, 4, 5, 6. Now we can say for each row in array div points, make that a list too, so that we can store stuff inside it. But we have to actually use the index notation because we are modifying the original. So for I in range of 0 to int frames plus 1, set array div points index I to equal a new list.
抄唔切。
So we've made an empty list of 5 plus 1 items, so an empty list of 6 items. Then we're going to say, for each item in that empty list, make it a list itself. Okay? That's how we're setting up our lists, our empty lists. Okay? Now that we have our empty lists, we can start storing values in them. So, for a row in a range of 0 to the total number of frames, we can say that array div points the particular row we're working on. We need a column, and that's going to equal some point.
How much do we need to go further?
Okay, this is good. We don't need to actually do much more. This column here is I, because we divided these curves into points I, so that is the column. The division point along the original curve is the column that it's in. So the row is here, the column is here. So for ease of syntax, we're going to change all of this I, here, to the new variable name column. So for column name,
唔係，佢話要俾先至係識新鮮外星人。
that should be about it. Now I'm saying for each row, make array div points, which is our new list. Let's set this row and this column to equal, it should be a line, array points line index row. Okay, we're essentially done. We just now need to draw our curves. Okay? So what we've done is we have created a list of lists, and each list is the row, and it has all of the column points in it. So we can actually then loop through our rows and draw our curves now, with one line of code. We can say rs dot add curve, and add curve takes one required parameter, and it is a list of points in that curve. The list of points is array div points, the particular row. Okay. So let's loop through each row. So for row in array, for row in array div points, let's just add a curve of this row. And let's test it. Starting point, ending point, and we have an error. Index out of range. Okay, so we go to line 22. And index 0 is out of range, which means that our list is probably not the right length, or something hasn't been set up properly.
其實咧，可唔可以問下佢仲要再學多幾多？如果再學就一定唔會得。如果呢個 point stop 咧都有機會 review 下，如果嚟緊 further 仲有咧，我諗就冇關係。